Our next topic is boundary value problems, and here's some motivation for what's to follow. So consider our model problem, y double prime minus 5y prime plus 6y equals 0. If we want to solve it, then you can use the auxiliary equation, which is r squared minus 5r plus 6 equals 0, which gives the roots r equals 2 and r equals 2. And in the example that's to follow, those roots 2 and 3, those are what are called eigenvalues. So we would say that the eigenvalues are not r equals 2 and r equals 3, but rather lambda equals 2 and lambda equals 3. That's one thing. The second thing is, well, once we find the roots, we can have the general solution, which is y of t equals a e to the 2t plus b e to the 3. Now, the important thing to understand, for us, there is no difference between a e to the 2t plus b e to the 3t and simply e to the 2t and e to the 3t. In the following sense, because note, starting from e to the 2t and e to the 3t, and only using addition and multiplication, we can get the general solution. Get y equals a e to the 2t plus b e to the 3t. So this is sometimes called a linear combo. So once again, for us, there is no difference between e to the 2t and e to the 3t and that linear combination. And in particular, in the example below, the building blocks, e to the 2t and e to the 3t, those are what are called eigenfunctions. Functions which are e to the 2t and e to the 3t. So in some sense, what you'll see in the next example, we'll ignore the constants a and b because once again, there is no difference between building blocks and the general solution. And in linear algebra, this is sometimes called a basis of solutions. And I'm hoping that this motivation will actually clear up some of the confusion in the following video.